Your agent has the right tool for the job, it just called the wrong one. Not because the model is dumb, because you gave it 3 tools named almost the same and a description that said code gets data. The model never sees your code, it sees a name, a description and a schema. That is the entire interface. If that interface is ambiguous, the model guesses and sometimes it guesses wrong. Welcome back to the CCA Exam Prep course, episode 5. We just finished domain 1. Today we start domain 2, tool design and MCP integration, 18% of the exam. One honest note up front. The public exam guide spells out domain 1 in detail. For domain 2, I'm mapping straight from Anthropic's own tool use and MCP documentation. I'll keep it to what the docs actually say. Start with the single highest leverage thing in this whole domain, the tool description. Anthropic's docs say it plainly. The description is by far the most important factor in tool performance. Not the model, not the prompt, the description. Here is the test. A poor description says, gets the stock price. A good one says what the tool does, when to use it and when not to, what every parameter means and any limitation like this data is delayed 15 minutes. The guidance is to aim for at least 3 or 4 sentences per tool, more if it's complex. Write it for someone who has never seen your code because that is exactly the model situation. A vague tool description is the number one reason agents call the wrong tool or fill in the wrong argument. Fix the description and a surprising number of the model is bad at tools problems just disappear. Next, the schema and the name. A tool definition has 3 required parts: a name, a description, and an input schema written as JSON schema. The schema is not just types. Describe each property inside the schema to what it's for, what format it expects. The model reads those descriptions the same way it reads the tools. Two design rules the exam leans on. First, consolidate. Instead of a separate tool for every tiny action, create PR review PR. Merge PR, group them into one tool with an action parameter. Fewer, more capable tools mean less for the model to disambiguate. The failure mode from the intro, 3 tools that all sound the same. That is what consolidation prevents. Second, namespace. When your tools span several services, prefix the names GitHub_list, PRS, Slack_send message. Now selection is unambiguous. The model knows which world each tool lives in. And design what the tool returns. Hand back only high signal information with stable identifiers, a slug or an ID, not opaque internal junk that wastes the context window. Now the part most people get wrong. What happens when a tool fails? A tool result can carry an is_error flag set to true with a message. The temptation is to return the string failed and move on. That tells the model nothing, it can't recover, so it gives up all loops. Instead, write an instructive error. Not failed, say rate limit exceeded, retry after 60 seconds. Now the model has what it needs to adapt. Wait, then retry. The error becomes a recovery instruction, not a dead end. This is the exam's framing of robustness. A well-designed tool fails informatively. The agent reasons over the error message the same way it reasons over a successful result. One more parameter to know. By default, the model can call several tools in parallel. Set disable parallel tool use to true and it makes at most one tool call per turn, which you want when later steps depend on earlier results. That covers designing your own tools. The other half of this domain is MCP, the Model Context Protocol. One sentence, MCP is an open standard for connecting AI applications to external systems, tools, data, and workflows. The docs call it a USB-C port for AII. one standard plug instead of a custom integration for every service. The architecture has 3 roles and the exam tests that you know which is which. The host is the AI application, Claude Code, Claude Desktop, your agent. The host runs one client for each server it connects to. And a server is the program that exposes capabilities, a GitHub server, a database server, a file system server. The rule to remember: one client, one server, one dedicated connection. The host coordinates them all. A server can run locally on your machine or remotely. The word server is about the role, not the location. So what does a server actually expose? 3 primitives. This is a classic exam recall question. 1. Tools. Executable functions the agent can invoke to do something. Call an API, query a database, write a file. Actions. 2. Resources. Data. The server makes available as context, file contents, records, a document. Resources are things the model reads, not actions it takes. 3. Prompts. Reusable templates the server offers, a pre-built prompt or workflow. The user or app can pull in. Tools do, resources inform, prompts template. If you remember nothing else from this section, remember those 3. How does the client actually talk to the server? 2 transports, and the choice is mostly local versus remote. First, standard input-output (STDO). The server runs as a local process on your machine. The client talks to it over standard in and standard out. No network, lowest overhead. This is the default for local servers. Second, HTTP, streamable HTTP, sometimes shown as SSE. The server runs somewhere else and you reach it over the network with normal HTTP authentication, bearer tokens, API keys, headers. This is how you connect to a remote hosted server. Same protocol, same 3 primitives underneath. The transport just changes how the bytes get there. Last piece, how this shows up in Claude Code and the Agent SDK, because the exam asks the practical version. You register a server in a config file .mcp.json or with the command Claude MCP add. Once it's connected, its tools appear to the agent with a predictable naming convention. The name is MCP, _, the server name, _, the tool name. So a list PRs tool on a GitHub server becomes MCP, GitHub, list PRs. When you see that _ shape in an answer, you're looking at an MCP tool. And you don't have to expose everything. You scope which tools an agent or sub-agent may use with an allowed tools list using those same full tool names. This connects straight back to domain 1. Least privilege is a design decision, not an afterthought. Let's apply it. Scenario 4. A developer productivity agent wired over MCP to GitHub, Jira and Slack. The problem, it keeps calling the wrong tool, posting to Slack when it should comment on a pull request. What is the right fix? Option A. Lower the temperature so the model behaves more deterministically. Option B. Write detailed, unambiguous tool descriptions, what each does and when to use it, and namespace the overlapping tools by service. Option C. Add a paragraph to the system prompt listing which tool to use in which situation. Option D. Give the agent more tools so it always has an exact match for any request. Walk it. A temperature changes phrasing, not tool comprehension. Wrong tool, wrong labor, gone. C. A system prompt list is a prompt, probabilistic, and it rots the moment you add a tool. It treats the symptom, not the ambiguous interface. Gone. More tools is more to confuse. It makes selection harder, not easier. The opposite of consolidation. Gone. B. Fix the descriptions and namespace the tools. You are repairing the actual interface the model selects from. Deterministic improvement at the source. That's the answer. Lock in 4 things. The model only knows a tool by its name, description, and schema. The description is the highest leverage thing you can fix. Consolidate overlapping tools, namespace across services, and return only high signal data. Make failures informative. An is Azure result with an instructive message lets the agent recover instead of giving up. MCP is one open standard. Host, client, server, 3 primitives, tools, resources, and prompts. 2 transports, STDO local and HTTP remote, tool surface as MCP server tool. That's domain 2. Next episode we move into domain 3, Claude code configuration, CL.MD hierarchies, /commands and path rules. Subscribe and I'll see you in episode 6.